Okay, so hopefully the audio will be clear on this. It should be clear enough for sure. So you can see our agenda for this recording. I just went through the Pearson online assignment 1 and not really sure what to say about it. Almost nobody turned it in. I think at each class I got maybe 2 or 3 people that did both lessons. Some people that did maybe one lesson. Even the people that did the lessons and turned them in, it looks like you only did the first question of each lesson. There's actually a way you're supposed to forward through questions until you finish them all. So I'm going to show you that in a second. And then even if you did all the questions, I didn't have anybody that got them correct. I'm not sure if anybody got any question correct at all. So instead of giving everybody a 0 on it, we're just going to throw that out, and I'm going to give you a new Pearson assignment for lesson 2, as you see in the third agenda item. First, I want to show you a little bit about Pearson and how to use it. Mainly how to complete the questions that I'm going to start assigning. We're really just going to be working on solving system of equations through substitution and elimination, probably for the next 3 or 4 weeks until we get that down, because we're going to do it in such small chunks. So with Pearson, I'm going to go in. I'm going to show you in Portal what it looks like. So I'm sorry, in Clever. Right, so in Clever, this is a favorite for me. I've already marked it as a favorite. If you don't know how to mark something as a favorite, if you'll notice when you hover over it, there's a little heart. If you click on that heart, which I've already clicked on these, it puts it in your favorites. If it's not in your favorites, you'll notice the heart is not highlighted or red or whatever you want to call it. If I clicked on it, there you go. Now it just added it up there. I'm going to remove that because I don't particularly want it to be a favorite. So then everything that you use is at the top, a little bit easier to get to. You probably don't have as many icons as I have anyway, though. So anyway, we click on this, and it takes us into Pearson. You'll get a screen that looks like this, possibly. Or you might get a screen, let me see if it looks like this. Yeah, you might get a screen that looks like this. I may just have this as a teacher. Regardless, though, if you'll notice, it says Envision Florida Algebra 1 2020, which is the same thing that it says right here, Envision Florida Algebra 1 2020. That's what you want to get into. That's your book. That's your book. It has tons of help in there. It has examples. Even you can get to information that I don't assign. If you need help on something, you can scroll through, you can do keyword searches, I believe. I'm not sure exactly what you guys see. Might be a little different. So anyway, I've assigned some work for you. As an example, let's go back to an assignment that you're going to have to do. You will get, actually, I don't, you're not going to have to do this. I still want to show it to you, though, in case you are working with it, with it yourself. So there's a table of contents. So this is all the stuff in the whole book. Whole book is online. You can get to anything you want. Let's see, is there a keyword search? I have teacher resource. Oh, here's a search up here. So we're working on system of equations. So let's just type that in. System of equations. Let's see what happens. And I actually haven't done this. I probably should have done it ahead of time. I wasn't planning on showing this to you. Yeah, there you go. Solving system of equations by substitution, what we just did. Solving system of equations by graphing, what we just did. This has tons of information in it for you. And I'm going to let your parents know it's in there too. So don't be surprised if they come to you asking questions. We are working with graphing again today because we didn't do, like I said, the first assignment on graphing. We struggled on the lesson where you had to take the worksheet and do the graphs and then send it to me. Again, most people didn't do it. It's not due until tomorrow. Well, technically it's due Friday, but tomorrow is the last day of school for the week. I'm not seeing a lot of work coming in from anybody, and the work that's come in has not been correct. So we're assigning another stuff to Pearson now to do this. I'm about to go over a tutorial to help you with it in a second. So anyway, let's say you go into this and you want to get help. Again, I may not have assigned this, but you can still go in, solve a system of equations by graphing and try it. I would just work my way through all of these if you're really struggling, if you actually care. Hopefully you do. You're not getting a free pass this quarter. It's definitely going to be an easy quarter, but you need to do the work. The very, very easy work. I mean, you only had 10 questions on the last thing that we did last week I'm talking about. So now, what is the solution of a system of equations? It gives you a system of equations. Again, a system of equations is just two equations. I'm going to go over this in a second, but it's two equations, one solution. So whatever solution we come up with will work for both of these equations. It'll make the left side equal to the right side. You don't even have to try it on your own when you're doing the stuff I haven't assigned. Just click on solution, and it'll tell you what to do. Use a graph. All right, well, step one, what do I do? Well, I graph the two lines. So it tells you which line you graphed in red, which line you graphed in blue. Step two, what do I do now? I've graphed the two lines. All right, well, it says the two lines intersect right here, which you can clearly see. All right, good. So step three. All right, well, then that is the solution for both equations. Now later it asks you some questions where you have to think about it. I'll just tell you one of the questions is, why is that the solution? Well, remember, every point on a line is a solution to the equation. So for this red line, every point, this is just a bunch of points that get super, super close together and eventually makes a line. Every point is an x and a y coordinate. So for example, this point right here that I'm kind of pointing to, could use my pen, I guess. This point that I was just pointing to, let me zoom in on this. Yeah, there we go. That point right there. Oh, I can't write. Shoot. It's not connected to a smart board, so I'm not able to write here. That point right there, though, I'll just circle it with my cursor. This point right here, that is 0 for x, because here's my x-axis, and I'm at 0. My y value is 6, so that point is 0, 6. So that point 0, 6 would make this equation true. We can plug it in, and if I plug in 0, this becomes 0. 0 plus 6 is 6, and then y is 6 over here. So 6 is on the left, 6 is on the right. Every point on a line is a solution to the equation that you just graphed. That means this point right here where they cross is the one and only point that is a solution to both of the equations. So this point looks like, well, it tells you right here, it's negative 4, 4. So if I plug in negative 4 for x here, it will equal, this right side will equal 4, because that's what has to be on the left side. Same thing down here. If I plug in negative 4 here, and I do the math, the left side is going to come out to be 4, because that's what y is going to be. So you can do the math. I'm not going to do it because the lesson today isn't exactly about that. So, oh, one more thing that people are not doing. When you're in the Pearson book, there are more pages than just the first screen you see. Look down in this lower right-hand corner where my little cursor is. If you'll notice, this is only page 1 of 3. This is what I mean by the assignment that some of you did turn in, so I do appreciate you turning it in at least, because very few people turned it in. You need to go through every screen, though. You need to click on this little arrow right here, and it'll take you to the next screen that you need to do. And then you go to the next screen after that. I think maybe only a total out of all my classes, maybe 2 or 3 or 3 or 4 people did that. So most people just turned in the first screen, which again is why we're throwing that grade. I will give some consideration to the people that at least turned it in when you do your next assignment. Maybe I'll add a point or 2 to the next assignment. All right, so that's how you use this. Again, when you go back, so if I exit now out of here, it'll just take me right back to the table of contents. I would just always use my little search tool up here. I tell you what activity we're doing or what content, what lesson we're on. All you gotta do is look it up. Again, you can look up, here's a neat little place too, concept summary. This is just a one-pager on, you'll have to zoom in a little bit. It just tells you a little bit about graphing equations. So it explains the different kind of solutions. We're going to talk about that later, but if you'll notice, when the lines cross over here, they have one solution. That one solution is where they cross. If you have the lines, when you graph them, if they are right on top of each other, like you can't really tell it in this graph, but technically this is 2 lines. Each of these equations, when you graph it, winds up being exactly right there. Well, that means that there are an infinite number of solutions because they're touching at every single point. Both of those lines touch all the way up and down. So every single point is a solution for both lines. If they never touch, then there's no solutions. Because again, they have to touch in order for it to be a solution, because the points where they touch means that particular point solves both equations. Well, if they don't touch, then all of these points only solve the red equation, or orange. All of these points only solve the blue equation. There is no single point that solves both equations, like there is here. Or here, every single point solves both equations. All right, so let's go ahead and go into the lesson part. So next slide. What is a system of linear equations? Kind of talked about it already. It's just two or more equations. I think I have that on the next. Oh yeah, we're going over that on the next slide. Then we'll talk about when is graphing the best option for solving a system of equations, because we could also use substitution, or we could also use elimination, which is the same thing as solving it algebraically. How do we solve it using graphing? We'll do that. And then what are different solution types? We already talked about that. One solution if they cross, no solutions if they're parallel and they never cross, or an infinite number of solutions if one line is right on top of the other. Right, so a linear system of equations. Again, a system just means it's a bunch of things that make up one unit, I guess you could call it, like a PlayStation system. You have controllers, you have a console, you might have a headset, you might have a microphone, who knows what you have in those things. But that is a PlayStation system. Individually, none of that stuff is very useful. It's only good when it's all working together in the system. It's all plugged in together. So you'll have typically multiple variables. Well, you will have at least two variables. If you have at least two variables, then you have to have at least two equations. You could have three variables and three equations, four variables and four equations. The key is, though, your number of variables will typically match with the number of equations. So here are a couple of examples. I didn't give any word problem examples, which was the first assignment. Again, grades below on that. You can still turn that in if you haven't noticed. I'd opened up a new assignment to be able to turn in work for more credit. I had people turning it in. So again, I'm not sure how grades are going to look this quarter. I guess we'll find out. So this is an example. I have two equations, two variables, y and x, y and x. Over here, again, I have two equations, two variables, y and x, y and x. They look very different. They're not the exact type of setup. As long as you have multiple equations and the number of variables matches the number of equations, that is a system of equations. Again, whatever the answer is, the final solution, that solution will work in both equations, unless there's an infinite number of solutions or no solutions. So next slide. Right, so when is graphing the best option for solving? I'm going to have to pause this, see if that goes off again. Let's see. So we like to graph the y equals mx plus b format. Hopefully you remember how to do that. At one point we got pretty good at it, and then we moved away from it and did other stuff. But this is y equals mx plus b. Y equals mx plus b. This is not y equals mx plus b. You could still graph them, but they're just not as easy to graph. So the situation when it's easiest to graph is one when you have it already in this format, y equals mx plus b, y equals mx plus b. Well, there is one problem with that, and we'll go over it at the end of this video. I'm not going to talk about it now, but this is your first clue, that it's already in this format. So now let's go ahead. I will graph. Let me graph one of these real quick, the one. So since that's the easy way to do it, I'm just very, very quickly going to graph it. So I start with I'm going to do, let's see, go to pen, go to red. Oh, I don't want to do red. We'll do green. So I'm going to do this one real quick. Y equals 2x plus 1. Well, 1 right there is my y-intercept. So I start there. Then my rise over my run is 2, but I need to change that to a fraction. So 2 over 1. So my run is 1 to the right because they're both positive. So I go 1 to the right from the green dot that I have over here, right here, I'm going to go 1 to the right, and then I'm going to go up 2, and I'm going to put my next point right there. And then I'm actually going to keep following that pattern, and I'm going to go 1 to the right and up 2, 1 to the right, up 2. This just helps me. Now I'm going to go 1 to the left and down 2, just to continue that pattern in the opposite direction. That's going to make it pretty easy for me to do a line, because I'm not going to use my drawing tool, so I can just get this done pretty fast. So there we go. It makes your line fairly straight. Should be good enough to figure out what the approximate solution is. So next, now I'll switch to, we'll do this one in blue. So again, rise over, well, starting at -2 this time. So there's -2. This time, rise over my run. I already have a fraction, so I just need to write the fraction here. 1/2. So my run, they're both positive. That's +2, +1. So again, I go, my run is right because it's +2. So I go over 2 this time. I run left and right. I rise up and down 2, and then up 1. So my next point is going to be right there where my cursor is pointing. So I put a point there, and I put a point there. I'm just going to keep going over 2 and up 1. Now to go to the left, I would actually go left 2 and then down 1, left 2, down 1, left 2, down 1. So now again, I can draw a pretty straight line. There we go. And if you'll notice, I'll even zoom in. Oh, I didn't do that. I don't. Let me see if this works. Yeah, I can't zoom in on my touch screen right now. I could go up there and zoom in on it, but I'm not going to worry about it. So if you'll notice, our point, purple, where they cross, looks pretty close to right there. And I think that if I would have done a perfect job, that's probably going right through the corner of 2 squares, which means my solution would be -2 on the x, so -2 right there, and then I'm matching that up with -3. That's what this point is right here. So -2, -3. Let me get rid of all of that real quick. So I think that's -2, -3. The way I can test it and find out if that's the exact solution is I can plug that back into the original equation. So just real quick, I'm going to get rid of all of this stuff. You can always rewind it if you really want to. I'm not going to get rid of the lines over there, so I'll just go ahead and erase over here. So I'll get rid of all of this. So if that's the solution, then -2, -3 should work for both equations. So let's try it out. So y is -3, so I'm doing the top equation. That would equal 2 times -2, because I'm just plugging in -2 for x now, because my -2 stands for my x coordinate, my -3 stands for my y coordinate. And then I just add the 1. Nothing, the 1 doesn't go away, so that 1 right there, I just add at the end right there. So again, this 2 came from right here, and it matches up with the x value right there. I just plugged this -2 in for this x right there. All right. So +1, I didn't mean to erase that. And then the y is the same thing. It just comes from the -2, -3 point that I think is my solution, and I'm just plugging it in for y from the equation. So now I get -3, nothing changes there. 2 times that is -4 plus 1, and I get -3 equals -3. So check. So that worked for the first solution. I know that is correct. Now let's go ahead and let's get rid of all of that. And we'll do the other. It's the other one. Right. So now I'm testing this one. So again, y is still -3. Now I have 1/2. That doesn't change. My x is now still -2 because it's supposed to work for both equations. But the rest of my equation is now subtract 2. So again, -3 stays there. 1/2 times -2 is -1. Subtract 2. So again, I get -3 equals -3. So yes, it worked for that. So it worked for both equations. That means this is my solution. All right, next screen. All right, so here we go. I've just done another problem, kind of the same exact thing we just did, pretty much, right? Yeah, I don't know how to do it. So anyway, I graphed the blue line. If you'll notice, I took -5, and I started at -5 right there. I then converted the 2 right here, not the x. Let me be very clear about that. I converted the 2 into 2 over 1 for my rise and my run. So I went to the right one. So I'm looking down here. I went to the right one and then up 2. And that gave me this second point right there. And then I just connected them with a line. So that's how I got the blue line. I did the same exact thing for the red line. I think I can delete all of the drawing on that. So for the red line now, again, I started at 4. My negative x means technically it's -1 over 1 for my rise over my run. So I went to the right one. So I went to the right one. So from this point that is circled, I go to the right one and then down 1. Actually, shoot. Let's make that +1 and make that -1. That's good. Wait, no, I'm sorry. That's wrong. Wrong. Scratch. I like to go +1 to the right. So this is my run. This is my rise. So +1 means go to the right, which I did, and then I went down 1 because -1 on the top means a negative rise, which is down. So that's how I get to there. Then I connect them both. So where they intersect, that is the one and only solution that will work in both of those two equations. Don't forget, that is your final answer. After you graph it, you need to give me the final answer. Just graphing it is not the point. You're graphing it so that you can figure out what the answer is. So my answer looks like it should be, if I look at this point right here, that is 3 on my x coordinate and +1 on my y coordinate. So this should be my answer. I can test that out. So I'm going to get rid of everything and rewrite that. I'm just going to do it the quick way. So I think that 3, 1 is my answer. I can test it out by plugging it back in. So my y value is 1, so I'm doing this one. X value is 3, so that's 2. 2 times 3, which is my x. Plugging that in for x, and then I still say subtract 5. So this is 6 subtract 5. So yes, I get 1 = 1. So that's a check. That worked. So now let's go ahead. I'm going to get rid of all of that. I'll have to rewrite it again, but that's fine. It's quicker to rewrite than it is to work for them. So again, my y value is still 1. Ooh, I don't know why that just slid over to that. Weird. Now that equals negative. So you still need that negative sign. You could even write -1 there if you wanted to, because technically that negative x is -1x. Times +3, because that's what my x is. This is my x, that's my y. And then +4 this time. Right, well, I get 1 equals -3 + 4, and I get 1 equals 1. So again, it worked for that one also. So yes, this is my solution to both equations. Perfect. So moving on. What if the lines don't cross at a corner? Okay, so this is a little tricky. I'm not going to go through all the math on this one. It's actually hard to go through the math because I am going to have to zoom in though. So let's zoom way in to show you what I'm talking about. All right, so, oh, I didn't mean to do that. Oh, I didn't mean to do that. There we go. All right, so if you'll notice, where these two lines cross is not exactly through the corner of a square. Actually, it's not close to both corners of a square. It's almost on the x-axis, but it's even a little above that. And it's definitely not anywhere near a corner when it comes to what is the value for, actually, I'm sorry. It's almost on the x-axis, which means y is almost 0, but it's not. It's slightly above the x-axis, and it's in between the 1 and the 2 on the x-axis. Oh, It's confusing. Anyway, you see that it's not exactly through the corners. That's what's important. So if I were going to come up with what is my solution, all I could really do is just estimate this. I can't tell exactly what number it's going to be. I know it's somewhere between 1 and 2, and it looks like it's a little past halfway. So I would say my x value is probably about 1.6. So my x value is 1.6, I'm guessing. So that's a 1.6, hard to write. My y value is barely over 0 because, again, this is my y-axis going up and down right here. That's my y-axis. So if this is my y-axis and it kind of runs into my y-axis right there, I would say that's maybe about 0.2 on the y-axis. So my y value would be about 0.2. So my approximate solution is 1.6, comma 1.2. That's my x value. That's my y value. I'm just taking my best estimate because without solving it out mathematically, graphing isn't a perfect way to solve that one. All right, so lastly, and then we're done. Can I zoom out? I hate when I do that. So let me zoom back in. We already went over this anyway, but there. So there are 3 possible types of solutions to any system of equations, not just when you graph. You might get one solution, and that graphically looks like this. So you have 2 lines that cross. The point where they cross means that that point is an answer for both lines, which means that is the answer to your system of equations. You might get 2 lines that look like this. They never cross. Well, if they never cross, then that means all of the solutions on this line are separate from all of the solutions on that line. They don't have any solutions in common because they don't touch. Because every point on the top line is its own solution. Every point on the bottom line is its own solution. They don't have anything in common. They don't share a solution. They don't touch. So you can read the bottom part there. And then in this last one, well, they do touch. They actually touch everywhere. So that means every point on the line is a solution. So you have an infinite number of solutions. Those lines are always touching. The key is wherever lines touch, that's a solution for both equations. If you need help, you can send me a message through Focus. You can reply to the posts in Teams, which you need to be reading those posts in Teams. That's the way I'm communicating for the most part. Focus messages I only send every once in a while, but I post a lot of information in the Teams application. And your next assignment on all of the stuff you just saw will be put up today. It'll be due Friday, but that gives you tomorrow to do it. It's not hard. It's only 4 questions, and I pretty much answered everything in this video.